Well, we've talked about combining two functions with addition, subtraction, multiplication, and division. These are the four basic operations you've probably used all of your school years. However, when you look at functions, there is a fifth operation that you can use with functions, and it's called the composite or composition. The composite symbol is like a little zero, a little O. So when you see this O in between two letters, F-O-G, we would read that as F of G. So that's the proper way to read that out loud. So this means to find F of G of X. Well, what in the world does composite or composition do? We know add means add, subtract means subtract. Whenever you need to do the composite, that's just another fancy word for substitute. So, what we will do here is you can rewrite F of G of X if you would like to as F of G of X, or you can simply take the G of X function and substitute it into the F of X. The order does matter. So whatever letter is written last, written second here, that's the function that gets plugged into the first one. So in our case, A, I would take these terms and I would substitute into the X in the first F function. So F of G of X is going to look like this. I take the 5x plus 6, but I don't want the x there. I'm going to substitute in 2x minus 1. So I will distribute, get 10x minus 5 plus 6, which gives me 10x plus 1. That would be the final answer for composition of these functions, or the composite function. Now, I said the order does matter. Here in example B, the letters are reversed. Remember though, you always use the second letter, which is the second function. That one gets substituted inside the first function. So when I look at this with my terms up here, this time I'm going in the opposite direction. I'm taking the 5x plus 6, and this time I'm plugging it into the G function, because the F of X gets substituted into the G. So, G of F of X, normally the G function would be 2x minus 1, but I don't want it to look like that. I want to replace that x with the function, and the function would be 5x plus 6. So notice here inside the parentheses is the f function, and it was replaced or substituted inside the g function. Now I'll distribute, and I get 10x plus 12 minus 1, which is 10x plus 11 when I combine my like terms. So g of f of x is 10x plus 11. Notice the answers are similar, but they're not exactly the same, so you do get different answers. Now, the last example, C, says f of g of negative 1. What you can do here, if you have already taken f of g of x, which we did, part A, bring over your part A answer, and just plug in the number they give you. So that would be 10 times negative 1 plus 1. When you work that out, you end up with negative 9. So if you have a number with FOG or with GOF, just take the previous answers and plug in that number. I hope this helps you understand composite functions a little better.